Here we have a SAT math question. Okay, there is a table over here. There is this table is about vocabulary test scores, and here in the first column we have test scores, in the second column we have number of students. So that is there's only one student with the test score 100, and there are 5 students with the test score 90 each. Okay, in this way we have category for the test score 80, 70, and 60 number of students. Okay, now let's go the information here. The table above shows the distribution of test scores in Mrs. Keaton's English class. Which of the following sets of test scores, if added, would change the standard deviation of the distribution the least? Okay, to answer this question, first let's understand what is meant by standard deviation. So standard deviation measures so how far the values in a data are far from the arithmetic mean. So if there are more values far from the arithmetic mean, then the standard deviation will be greater in value. In case in a data, if all the values are very close to arithmetic mean, and the value of the standard deviation will be smaller. Okay, now so let's go with the data over here. And in this data, there is only one student with the test score 100, and there are 5 students with the test score 90. So in this data, first we have to find arithmetic mean. So I think so approximately we can find the arithmetic mean in the data over here. So how do we have to find that? So now look at the data and look at the category where we have more number of students. So this is the category where we have more number of students. That is, there are 10 students with test score 80 of each. So that means that the central value of the given data is 80. So the approximate mean can be considered as 80. That is, approximate test score in this data is 80. So if I find the exact arithmetic mean, it will be a little more than 80 or little smaller than 80. Anyways, we can say that 80 is approximate mean. So because there are more students in the category of test score 80. So that's the central value. We can take the central value as arithmetic mean. Okay, now we have to find how many values are far from this arithmetic mean. So in case there are more values far from this arithmetic mean 80, whether the values are above the test score 80 or the below test score 80. So if there are more values far from arithmetic mean, the standard deviation will be greater. If there are less values than arithmetic, I mean the values in the data, almost all the values in the data are closer to the arithmetic mean 80, then the standard deviation will be smaller in value. Okay, now according to the question, which of the following sets of test scores? We have 4 sets of test scores in the 4 options, and we have to find the one which changes the standard deviation of the distribution the least. So for example, let's consider option A. So we have 4 values. So if I add these, we have to consider each value as a test score. If I add these 3 test scores into the data set, so the standard deviation will become greater or smaller. So consider all these 3 test scores, 60, 60, 60. If I add these 3 test scores into the data, all these 3 test scores will be included in this category. So what will happen? So then we'll have more number of values far from the arithmetic mean 80. So definitely the values in option A will make the standard deviation greater. So I don't think the option A can be correct. Anyways, we can go over the option B, C, and D and then decide. If I go to option B, there are 3 test scores, 60, 100, 100. This 60 will be included in this category, and the 2 100s will be included in these 2 categories. Again, we have more values far from the arithmetic mean 80. So the set of values in option B also will increase the standard deviation, will increase the value of the standard deviation. Okay, now let's consider the set of test scores in option C, 70, 80, 90. So when you consider 70, 70 is close to 80, and 80 equals to the mean 80, and 90 is also close, even though 90 is greater than the mean 80, but it's close to 80. I think adding these 3, adding the set of these 3 scores into the data, so will decrease the standard deviation. Anyways, let's go over option D also. In option D, we have 3 values, and all these 3 values, 90, 90, 90, are close to 80 only. So now it's very clear, option A cannot be correct, option B cannot be correct, because in option A and option B, when I add the set of test scores into the data, it will increase the standard deviation, because when I add these 3 values and these 3 values into the data, we'll have more values far from arithmetic mean. So the standard deviation will be greater in value, because standard deviation measures how far the values in the data are getting deviated from arithmetic mean. So now option A and option B cannot be correct. So either option C or option D can be correct. So how do you have to decide option C is correct or option D is correct? In option C and option D, so in both the options, the 3 values over here, the 3 values over here are close to arithmetic mean. So but when I go to option D, So none of the values is equal to arithmetic mean. All the values are close to arithmetic mean, but all the values are a little far from the arithmetic mean, 90. But when it comes to option C, so this value, 1790, both of them are close to arithmetic mean, but one of the values equals to arithmetic mean. That is, this particular value, this particular test score 80 is not getting deviated from arithmetic mean, it equals to arithmetic mean. So when I add these three values, these three test scores into the data, so the standard deviation of the distribution will be the least, because one of the values in this set of test scores equals to 80. So there is no deviation because this 80 is not getting deviated from mean. So, but here all the three values are getting deviated from the mean 80, but here only two values are getting deviated. Even those two values are close to mean. So one particular value is not getting deviated. So option D is also incorrect. When I take option C, that is when I add this set of three test scores into the data, it will change the standard deviation of the distribution the least. So the correct answer choice for this question is option C.